this is equal to p square plus 4p2 plus q square plus 3 plus 3. And this is bigger than p plus 2p. Right. So some people may not have the link. Right. So we do see that it is bigger than. So this quantity is bigger than p plus 2q whole square. Okay. Right. If because p is bigger than q, so we have used the fact that p is bigger than q because we have used the fact that p is not equal to. So I don't know, but I don't know if what happens if you take this. Right. So we get p square plus 4q square plus 1, okay, minus 2p. So now I'm taking just the square. Okay, no, I should take plus, right? Sorry, this is bigger than that. I should be taking plus. Yeah, I want to say maybe it's less than that, and let's see if that works. So p square 4q square plus 1, and then yeah, it's 2p only. 2p and maybe 4pq, right? Plus 2. No, 4q. Sorry. Is this bigger than p square? Wait, what happened to the others? I did open Google Meet in case someone joins there because they didn't stick the link naturally. I just mailed them. Shana, can you check if it is bigger? Ah. Just a minute, okay. I'll send it to Nagesh. No. Is it bigger? No. I was feeling that it won't, and it is not. No. There is no way you can say that, right? This thing always. Can I say this is lesser? This is bifurcating into all kinds. So can I say this is lesser? That's also hard to say, right? And maybe one.
I think I was able to prove that this quantity lies between 6k1 plus 6k2 plus 4 whole square and 6k1 plus 6k2 plus 5 whole square.
Okay. So let's see that because either way this is not working. Okay. Yeah. So everybody is here. I don't know. Wait. Oh, I didn't let her in. Anyways. Okay. So you're saying it is between 4 and 5 or something? 6.
Yeah, 6k1 plus 6k2 plus 4 and plus 5.
Okay. I'm but what I was thinking this will not be possible. But okay, but let us see how you have done that.
So the quantity in between p square plus 7 pq plus q square, I had expanded it and I have got that whole value like 36k square and all. And when I expanded the other terms also, they were all of the form k plus k2 and k into k2. So I could easily compare them.
Right. So yeah. So in this case, you have told me the expansion, but can you tell again? 54. 54 was it? K1 plus K2.
Yes, 54 k1 plus k2 plus 252 k1 into k2 plus 9.
Now let me see this one. So you tell me this one. 36K. Yeah, it's easy to. Is okay. I don't know if it's easy, but yeah, easier to compare. Then 16, and what are the other things? 50, 50, 48.
Yeah, 48
48 K1 plus K2. And
and 72.
sorry, 72. Right. No, so this is certainly. So you're saying this is yeah. This okay. This I agree. Fine. This is okay. This one is okay. One can yeah do it. But then this side, I am skeptic because then basically my method would have also worked when going, because this is just I mean this is just p plus q plus 3, right? And it would come from there because this k1 k2 is not really important here, right? I mean maybe a slightly useful value is bigger than 6, but otherwise the form is not useful. But let's see if it works. This and 25, then 30 is it 30? No, 60. Oh, 60.
Yeah,
60.
60.
Oh, it's working here.
And then 180.
So that's the problem, the 180. Let's see how you deal with that. So how do you compare this? No, I don't. Yeah, same problem, right? Is you see this we can erase, right? Should I erase that? This one. And this we can erase and write 6 here. But then there is a major problem. See, 9 you'll erase, can write 16 here. But then how do you? No, that is not true. Is it, or is it something else? I'm doing wrong. 72 is 72. How can you say this is bigger than this? In fact, it is not. Oh, yeah, it is. Yeah, it is still bigger. This middle term is bigger, and that's what I was telling there also, that we cannot say. For some values of K1 and K2 maybe, but in general we cannot say. Right? This will usually not be true. In fact, that's why I didn't follow that approach. Okay, maybe you did some calculation mistakes, right? Or I don't know.
Sir, can you recheck if it is 180?
Oh, the 180 thing? Yeah, I think, okay, this is 180, right? So why is it? 6 is a 36. Oh, 36.
It's 72. I think I made a mistake.
72, right. But then it's even worse. It will always be, yeah, this will always be 72 in these kind of numbers. That's why I did not continue the approach. Yeah, because that 2pq was not changing. That was always 2pq into this kind. Right? But then it's even worse, right?
Yeah, it's worse.
Right. So it doesn't work. So this approach doesn't work, and even what I am saying here doesn't seem to work. So I proved this, that this is bigger than 2p plus 2p plus 1, but I'm not able to show the other thing. So I don't know. I mean, I would have, if I was doing this exam, I would have abandoned this approach long time back. But anyways, there's a new approach, and let's try that. Okay.
So what if we take mod 7, the whole expression?
Mod 7. That's 7. That's a reasonable thing to do. If it works, then it's very, very good. So then p square plus q square is congruent to a square mod 7. Right? So what is, do we get mod 7, 1, 2, and 4? Right? This is the only possibility is mod 7, right? So then the problem that comes as well, there are many ways this can happen, right? This could be 1, 1, and this could be. And then you have to take that p to be 7, q plus 1, q to be 7, and then try. I don't know. That is there, but doesn't directly give us any. So, yeah, but there has to be something simple that works here, right? In this kind of questions. So maybe one more thing to try. Obviously, so this would be to try like this. Q, and the P. The P has to divide. This sort of we already said earlier, and it was not useful, right? That also does not seem to work. The answer is no. What is it that we are missing about distinct primes? Let's try one more thing. So there is one more thing that we can try. You could look at this as a quadratic equation in P. So if you do that, then what happens? Comes like this. And so we should do this. So this is like this. Right? Right. And then if this has to have so what are the roots of this, right? Sort of. So you will notice that in the roots you get something like this. B square minus 4ac. This is the b square minus 4ac, right? This you get the formula, right? So this has to be a perfect square. This has to be a perfect square now, right? Because the roots of the quadratic would be this, and minus, but minus is not possible here. P is positive, prime positive. Okay, like this has to be P. If you really solve the quadratic, this has to be P. Okay, so I mean, for this to be an integer even, this has to be a perfect square, right? This inside thing. So the inside thing has to be a perfect square is what the point is. So, but this may be simpler to deal with. You see my point, yeah? Because we don't have PQs now, right? So we have 49 minus 4 is 45. Equal to, looks easier. This looks like an easier question slightly. Okay, where Q is a, what happened? Somebody, okay, let's just close that. Please save the links, okay? Yes. Okay, now it's there in the mail. Yeah. So what can we say now? So basically this 2a square we can sort of forget and just write some b square, right? Because it's also a square. But just notice that that is even. B is even, and so C is odd. C is odd. Okay, so the problem reduces, becomes sort of, at least, yeah, not reduces, but whatever, comes to this. What can we say now? This looks like a difficult, I mean, I can do this, but then this seems like some difficult question. Bell's equation and so on. You can stick with this only, but I'm just writing it in case one of them is more useful. Yeah. Now it is not very difficult to show maybe that this is to find solutions of this and so on.
I don't think 5 plus a whole square quantity can ever become a whole square.
No, why? Why this cannot happen?
No, I'm not sure, but just by taking examples, I
This
saw.
way, yeah, okay. Uh, I don't know this. Yeah. This is one of maybe is it one of the difficult questions, or are we all not able to just do it? So q square has to divide this. So yeah, so you have to say that q divides c plus b, because c plus b is sort of the bigger number, right? And if q does not divide c plus b, then c plus b is less than 45, right? And then it's a trivial case from there, right? So q has to divide c plus b, because if q square divides this and 45, then 45 has to deal with the rest. Then it kind of makes q very small. There are some very small possibilities for q that will come from here, which you can easily do. So q divides c plus b. And yeah,
But we
then
don't know any of the values, right?
we don't know any of the values. And now if q divides c plus b and also q divides c minus b, then what do we get, right? Then we get that q divides both c and b. Is that right?
Yes.
So because it'll come, 2 will come, and 2 you can already put and check it doesn't work, whatever. Then q has to divide both c and b. But if q divides both c and b, in that, I mean, if you take that case, then it's a trivial, then I think the equation becomes trivial, right? Because because then the equation sort of will become, you can write b as q times b1, and then this will become c1, and in fact this will go away. And then you can find this you can easily solve, right? C1 square minus b1 square is 45. You can easily solve that, right? Because some small c minus b, c plus b, small factors, possibilities. Then you check that for none of them, whatever, right? You can, this is easy. So that case is easy. So we should basically now focus on the case when 45 divides 45 divides c minus b, or rather, so what is the situation? It's not just divide and so on. It is like this: 45 q square is equal to. So basically, from here we get some very simple cases to work with. Okay, c minus b and c plus b, and so q dividing both, that case we have solved, right? So it means that q has to only be with c plus b. So then the possibility becomes that c plus b is q square and c minus b is 45. Okay. And this is also pretty easy. I will leave it to you to work this out, because you can solve for c and b, put and do all that, right? This also I will leave, okay? And similarly, there are some other simple possibilities. So will you do this? Okay, like, it can be 9 times, and this becomes 3. Simple cases, okay? And this is how the difference of square equal to something having less prime factors is usually dealt with. Is it okay? I mean, this is a very standard, like in books, there are several problems like this in the Diophantine equation. Okay? Basically, when you have a difference of squares, you make it a difference of squares, right? And then one side has very few possibilities for prime factors, right? I mean, this is just, and so you just take all the cases in the sense that you take, okay, c minus b is, one possibility is like, it's 3q, and c plus b is what, 15q, right? And these are all small cases which you could just work out, and there are not many cases, maybe 7, 8 very, very simple cases. Okay. So please do this, and then you find the Qs for them, and then you use those Qs and show that no P works, or P equal to Q, whatever, right? So that seems to be the solution to this problem. That seems to be the way. Small casework is there, which you have to work. I mean, is this okay? Like, fine? What I'm saying?
Yes, sir.
Right?
Yes.
So yeah, like for example, if you take this case, then C becomes like, Q square plus 45 by 2, and then you have to put in check. Like then B becomes C Q square minus 45 by 2, and you put it and you get some equation only in Q. So you would get this find Q there, right? And yeah, won't it? Yeah, so very, very simple. And this seems to be the way. And this is a very standard way, this discriminant method, and then coming and doing what we did now, right? This case work. These are not just I am doing, this is very standard trick that is done. So, yeah. But maybe we can just once also look at the official set, like if it is easier and whatnot, right? So let us just see, or any solution that one can find online, but it has to be correct. Right? Where do you find the official? The problem. Let us go for the official page. Right? RMO fast. So that's the thing. You see, you have to. So what do you learn from it? That you have to be really fast at these things, because some cases will not work, and then you have to know that it will not work to get the hint, and then you have to change the approach. You have to have several approaches. You have to have the intuition which one will work or not, and like that you have. Okay. Like this one would have simplified. I could see a little earlier, so I did this. Okay, it would only become a difference. But without practice, you would not. RMO 2001. RMO solution. Right. Did anybody find solutions? Hello?
Yeah.
Yeah. So which who's Cinta or
ISI CAL.
oh, but is that the paper or is that ISI CRMO?
No, I just googled official solution for RMO 2001 PDF. The first link.
This one only, right?
Yeah.
Right. Oh. This one, right? Okay. So if you look at the solution, then so they have done something different, right? Slightly different, right? At least. So I'll just make it bigger. Can everybody see?
Yes, sir.
Okay, good.
Yes, sir.
Right. So they have also gone for difference of squares, but they have done it like this. Did we do this? Yeah, we did this, right? But then we didn't like take it forward, right? Yeah, so I had done this at some point, right? This P plus Q whole square and this, but then I said, okay, P will divide this and so on. Oh, okay. So there's a fundamental error. Yeah, we left it, right? So let me write here and tell you the idea before you look at the I got it. So see, in the end, we also kind of do the same thing when in a long winded way. Okay. So in the end, what kind of thing do we have? We sort of have like 5p square or 5q square, right? And here we have a difference of squares. You guys agree, right? This kind of thing we had, and here when we came here, then we said, okay, now there are some or maybe we had some other number here. I forgot what the number was. Anyways, even if it's 15, 45, I think it was. Something like this, right? So then what happens? You do, okay, m minus n, as I just said, right? You do all the cases. It's 3p and m plus n is 5p. And then like that, you do the cases, okay? We did it here. But when we did the factorization, this factorization, see, this was a very nice factorization that I think you guys did not do. I sort of wrote this, right? So when we wrote this and we got this, we had written here. At this point, only you could have done, this is the same situation that we had in the end. Do you guys agree, right? Difference of squares and one side having less number of prime factors, right? And then here we could have, instead of just saying P divides 1, we could have just gone for the case. Right? Again, same thing says that there are not many cases, right? For instance, what could this be? One case is that this could be P, but that's just not possible, right? So it could be 5. It could be 5P, and this could be, then what has to this be? It has to be just PQ. This is one case, right? And similarly, we check the other case. This is 5PQ, and this is 1, and so on. Because that's bigger than that, so it's 1, and that's it, done. We didn't take it. So there we got stuck into the divisibility thing. Is it fine? Right?
Yes.
We didn't just equate, we just got stuck in the divisibility nonsense. But here I sort of equated and we did it. Yeah. So anyways, it's because, I mean, you are not dedicatedly solving because you're listening to me also, right? It's like a class. That's it. And I'm also not dedicatedly solving, I'm also speaking. So it can happen, it's fine, but you have to get better at it. Yeah. That's the problem. So no problem. And but you look there, that's all they're doing. Right? You see, this is equal to 5PQ, 5Q, and this is equal to P, and then all those small, like this is equal to PQ, that equal to 5, this equal to that equal to 1, and then you get the markers. So in fact, there are other solutions. And in fact, what we were doing also, one of those cases would give you some solutions, right? Of Q and so there are other solutions. So it is wrong that there are no other solutions. Okay, so this is okay. All right. So this is what has happened so far. Okay. So can you summarize what you learn from this? We don't learn any number theory, but what do we learn like in solving? Okay. Anyone would like to summarize? How would you summarize the learning? That is very important to do. So, well, as I said, when you look at this kind of equations, there are the things like difference of squares, and that is the method that we approached. Then there is like the approach of putting it between two squares. That's another approach. Then there was discriminant method. That's another approach. Using modulo, that's another approach. You see, we tried all these approaches, right? And in the end, we found that one of it worked, right? One of them we sort of got, but we did not really take it from there. Okay. So one thing is clear that one has to have a lot of approaches. Okay. And in general, these are one of these approaches work. Yeah, this is the thing. But one thing that I can tell is that you have to be faster at this. You have to practice so that you can start with an approach and know if it's going to work after some time. Okay. And yeah, that is, you have to just practice more to know what is going to work and what is not good. Right. So, but is it clear? Did you guys learn any new approaches today, right? The new approaches we had and the solution and so on. Okay. So keep that with you. And maybe there are these few problems that you guys can also try, which is related to this so that you get good at or better at this. Let me share it. And then that will be it. That will be the class. One question. But just give me one. So there is a book. There is this book, and at this point, I could tell you to do certain problems. Okay, so you can just download this book. Okay, online. Just download it. You cannot then. So obviously, go to the section of elementary method. Okay, and then which one is the most relevant here is the factoring method. Don't look at the other methods first. Only focus on the factoring. Okay. You can read all this, but probably I don't know if you'll understand. But look at these kind of questions. You sort of one side you factorize and the other side is the number, and then you take the case for. Okay. That kind of thing is there. I mean, first problem they've given a little hard, but you have to just it's example 2, example 3. But more important than the example, it's up to you whether you want to do the examples or not. But I will be most interested if you can. These are not easy. These are tricky problems. This book has. Okay. Anyways, I mean, go and have a look at this. If you, so maybe I'll just take my word back. I'll just say go and have a look at this if you want, because it's a little, yeah. We're good at algebra also. Okay. Have a look at it. This is the book. This particular chapter, I have few problems. I don't know if you will be able to enjoy it much. It's a little hard. Yeah, and then just continue solving the problems. And the RMO questions continue solving. Okay. And so this is what we did today. Then we will do the rest of the questions, means the other 1 or 2 questions we had. But maybe also 2002, let me tell you which problems try for next time. You don't want to see the solution right away. And you guys can also check out the solutions later. Okay, that's you should do that. Where is that? Problem answer. This cannot be. Anyway. But their official website was there, right? Fast. Maths. So do get a 2002 now, or 2002. Okay, it's with the solution. So it's up to you now. Don't look at the solutions first. Okay. Yeah, not question number 2. I'll tell you which. Right. Yeah. Try question number 3. You can note it down. Question number 3. Oh, not many number 3. 3 and 7. Okay. Question number 3 and 7. And obviously we'll go faster next time. 3 and 7 and whatever is remaining from the. All right. So maybe then we'll stop.
Sorry, which year is this?
2002.
3 and 7.
3 and 7. Okay. And in the other classes, we are doing the other topics. So maybe then we'll start trying more problems. Maybe polynomials problem also. And geometry also we did at some point. Slowly will come in. So RMO is not, it's not a one-day thing. Over the years. Okay. Okay. So the homework is set. And that's it. Thank you. And then at 9, we will have a class. Okay. I'm ending the meeting.